All right, we're going to go over it. So 8, 2 was your arithmetic sequences, right? So ones that when you add the same thing each time, whether it's positive or negative, you're adding the same thing each time. So number 1 says determine whether or not the sequence is arithmetic, and if it is, find the common difference. So are we increasing or decreasing by the same number each time for number 1? We're decreasing, right? 3 minus 5, 1 minus 3, negative 1 minus 1, and negative 3 minus 3 all gives you what? Negative 2. So it's a yes. It is arithmetic, and D equals negative 2. Number 2 says write the first 5 terms of the arithmetic sequence. So the first one's given to you. It is 8. What are we going to do to get to the next one? Add 3. 11. Add 3. 14. Add 3. 17. Add 3. 20. First 5 terms have to include the first one that's given. Thank you. Bye. I'll see you in a little bit. Number 3, using the information from number 2, find the formula for A sub n for the arithmetic sequence, and then find the sum of the first 25 terms of the sequence. So a couple parts here. First one is find the formula. So an equals a1 plus d times n minus 1. That's one of the formulas we had to know for this section. What's a1? 8. Good. What's d? 3, and then n minus 1. If we distribute it, an equals 8 plus 3n minus 3. An equals 5 plus 3n. So without distributing it, 8 plus 3 times n minus 1. With distributing it, 5 plus 3n. Remember, if it was like multiple choice, only one of them is going to be there. Okay. If it was open-ended, what? Yeah, no, then it says find the sum of the first 25 terms of the sequence. So the second formula for this equation, or for this section, was the sum, or the partial sum of arithmetic, which is n over 2 times first plus last. 1, I haven't finished it. I'm toying with the idea of a little bit of both. Yeah. All right, n over 2. So if it's 20, the first 25 terms, how many terms are in the sequence? 25. What's the first term in the sequence? 8. How do I know the last term in the sequence? Good. I'm going to plug 25 in. And I can plug it in either of these places. So 5 plus 3 times 25. Or 8 plus 3 times 25 minus 1. Either way, you get the same answer, which is 80. So I get 25 over 2 times 88. And then 2 goes into 88 44 times. And I get 44 times 25. 1100. Okay, so first one, either of those answers I would have taken. Second one, 1100. Questions on that one?
Are the numbers going to be that big?
Sure. Sure. Yeah, there will be some multiplying this time. Correct. You'll either have a 4 function or you'll have nothing. Yeah. All right, 4, find the sum of the first 50 positive multiples of 5. First of all, what's a multiple of 5? 5 times 1, 5 times 2, 5 times 3, right? So 5, 10, 15, 20, so on and so forth. So the first 50, first of all, it's a sum. So n over 2 times first plus last. The first 50 tells you n is what? 50. What's the first one? 5. So if the first one is 5 times 1, what's the 50th one? 250, or 5 times 50, okay? So 250. I don't want you to have to write out 5, 10, 15, 20 until you get to the 50th. Like, that would be a complete waste of time. So sometimes you have to understand the pattern. If it's the first one is 5 times 1, then the 50th one would be 5 times 50. So then I get 25 times 255. 255 times 25. 6,375. And then 5 says find the partial sum. So I need to use the same formula, n over 2 times first plus last. But I don't really have any of that yet. I have to figure out n. So what's the rule? If the bottom is 1, what is my n? The top number, okay? If this was not 1, if this was anything but 1, what do you do? Good. Top minus bottom plus 1. So this time it's 10. And then to find the first, I plug in the bottom number. So 2 times 1 minus 3 is 2 minus 3, which is -1. And to find the last, I plug in the top number. 2 times 10 minus 3, 20 minus 3, which is 17. And I get 5 times 16, which is 80. Questions on that one? We're good on A2, yes? Okay. So this question came up from a couple of you in the homework. This is 7. It says, find the sum of the finite arithmetic sequence, sum of the integers from -40 to 50. So if it's a sum, I need n over 2 times first plus last. And what I am given is the first one and the last one. So I have -40 plus 50, okay? Now I got to figure out n. And what I would say is if it's hard to figure out n by like counting them, that's a lot of numbers, right? And you're unsure, do I just say that that's 90? Is it 91? I would pick a smaller set of numbers and figure out the pattern. So if I just was counting how many numbers are between, let's just say, -1 to 2, for example. It's -1, then 0, then 1, then 2. How many numbers are there? 4. So it is not just 2 minus -1, right? It's actually that plus 1. So if I start at -40 and I go to 50, I would have 50 minus a -40 plus 1. So unless you start at 1, you always have to add 1 to the difference. If you start at 1, 1 to 10 is 10, but 0 to 10 is 11. So if you start anywhere other than 1, you have to take, and even if you started at 1, you could do the same thing. But if you start at 1, you just grab the second number. But if you start anywhere else, you have to do the second number minus the first number plus 1. Because the second number minus the first number is the difference between them, but it doesn't include that first one. So this was 90 plus 1, which is 91. So this is 91 over 2 times -40 plus 50. 91 over 2 times 10. 2 goes into 10 5 times, and 91 times 5 is 455. So if it's a huge set, obviously I don't expect you to count from -40 to 50. And if you forget, do I add the 1 in or not, grab a smaller set and see what happens with those numbers. See if you have to count or not. The rule is if it's not 1, last minus first plus 1, just like we do with the sum, okay? Any other questions from the homework? Yeah. All right, so 8 says, same thing. Find the nth partial sum of the arithmetic sequence. I need n over 2 times first plus last. So it says n is 17. It gives you that one. The first one is 3.9. I've got that one, okay? What you don't have is the last one. So you can either take 17 and you could figure out what the difference is and keep adding it or subtracting it until you get to the 17th term, or you can set up your equation. So an would equal 3.9. The common difference here is -2. D equals, 0.2. -0.2. So minus 0.2 and minus 1. So if I want to find the 17th term, I get 3.9 minus 0.2 times 16. 0.2 times 16 is 3.2. And I know that last number is 0.7. So 17 over 2 times 4.6. 2 goes into 4.6, 2.3 times, and 17 times 2.3. And then move your decimal ones. 39.1. So you had to find the last one that time. Any other questions from the homework? Okay, geometric sequences. Get it open. Geometric sequence and series. So in this section, we're going to learn one more equation to find like the a sub n term. And then we're actually going to learn about 2 different types of sums when it gets to geometric. So first of all, what is geometric? Geometric is a sequence where the ratios of the consecutive numbers are the same. In other words, you are multiplying times the same number each time. So with arithmetic, we are adding or subtracting. With geometric, we are multiplying by the same thing each time. So if I take A2 and I put it over A1, and I take A3 and I put it over A2, and I take A4 and I put it over A3, they should all reduce to be the same thing. That thing is called the common ratio instead of common difference, common ratio, and the symbol we use for it is R. Now, it does say R cannot be 0 because what happens when you divide by 0? Undefined, right? So you could never do that. Like, you can't have an undefined geometric sequence. All right, so first example, determine whether or not the sequence is geometric. So look at A. I'm going to take the second term and divide it by the first. So 12 divided by 3, 48 divided by 12, and 192 divided by 48. What's 12 divided by 3? 4. What's 48 divided by 12? 4. And then probably easier than dividing 192 by 48 is multiply 48 by 4 and see if you get 192. So sometimes the bigger numbers, it's easier to go the other way. And it is, which means this is a yes, this is geometric. It didn't ask for it, but if it had asked, R would be 4. Do the same thing with B. So 1/2 divided by 1 is what? 1/2. 1/3 divided by 1/2 would be the same thing as 1/3 times 2 over 1. Is that 1/2? No. So this is not geometric. It only takes one pairing to not work. So if one works and the other one doesn't, it's a no. It only takes one to make it a no. Yeah.
Is it the same way as the arithmetic where like if it goes down, it's negative?
Well, so if it goes down, it would be dividing instead of multiplying. So like if you divided it was 1/2, then you're multiplying by a half, but technically you're dividing. But the only way it changes signs is if it's like a negative. So if R is a negative, it will go back and forth from positive to negative like that. All right, example 2, write the first 5 terms of the geometric sequence. So this time I gave you A1 and I gave you R. What are we going to do to A1 to find A2? Multiply by a half. So if A1 is 1, then A2 is 1 times a half, or a half. A3 would be a half times a half, which is 1/4. A4 would be a fourth times a half, 1/8. And A5 would be 1/8 times a half, 1/16. Remember that first one given is part of your answer. If it says the first 5 terms, you have to include it. Questions on that one? All right, finding the nth term. So if we're counting these formulas, this is the third formula that we got to know. This one is AN equals A1 times R to the n minus 1. So when you're doing arithmetic, you're adding the D, you're adding the D times n minus 1 because you're adding with arithmetic. For geometric, you're multiplying by the R. All right, so example 3, write the first 5 terms of the geometric sequence, find the common ratio, and write the nth term of a sequence as a function of n. So I have AN equals A1 times R to the n minus 1 as my equation. AN would equal A1, which is 9. Oh, sorry, wait, first find the first 5 terms. Just kidding. Write the first 5 terms first. Okay, this is not only geometric, this is also called what? Recursive, because it says use the one before it. So what are we doing to the one before it each time? Multiplying by 2. So if A1 is 9, then A2 is 9 times 2. Good. And A3 is 18 times 2. Good. And A4 is 36 times 2. Good. And A5 is 72 times 2. 144. Good. So that's the first 5 terms. That's the first part. Then it says find the common ratio. So we said it already. What was R? 2. Good. It's what we multiplied each time by. And then, so that's the second part. And then the third part says write the nth term of the sequence as a function of n. So an would equal my first term, which was 9, times 2 to the n minus 1. Questions so far? So here's what's so important, and people mess up when they try to do these things. If I wanted to find the 5th term of the sequence, let's just say, and you plug in n to the equation, the only thing that gets the exponent is the r. So you cannot multiply 9 times 2 and then raise it to the power. You are just raising the 2 to the power and then multiplying it times 9 at the end. Every year somebody messes it up. So be careful. The exponent is only on the r. So it's only on the second number that's there. You do that first, and then you'd multiply it times the number on the front. All right. Example 4. Find a formula for the nth term of the geometric sequence, then find the indicated term of the geometric sequence. So I want to find the formula first. an would equal a1 times r to the n minus 1. What is A1? 3. What is R? 12 to the n minus 1. Now if I want, so that's the first part, find the formula. Now if I want to find the 7th term, what do? Plug in 7 for n. So on something like this is when a calculator would come into play. I would not expect you to do 12 to the 6th power. But there are going to be questions that you will not have a calculator, or you'll only have for a function which doesn't have the exponent. You'd have to multiply it out the whole time. So 3 times 12 to the 6 is 2,985,984. And then that times 3 is 8,957,952. 8,957,952. Questions on those? All right, example 5, find the indicated term of the geometric sequence. This time, this is where it gets weird because we are jumping terms, okay? All right, so now we have the first term and we have the 4th term, right? And it wants the 10th term. So to find the 10th term, I want to find the equation. To find the equation, I need A1 and I need R. The only thing you have right now is A1, right? So there's a couple different ways to do this, so pay attention. If you jump terms, if you literally go from 2 terms that are not consecutive to each other, sometimes you can try to figure it out. Like, what would I have to multiply by to multiply by to multiply by? The bigger jump in between there, the harder that's going to be. So we manipulate the equation so that it works. We put the bigger base of what we are given. So we're using A1 and we're using A4. We put the bigger base of what we're given on the left-hand side of the equation. So A4 goes here. We put the smaller base of what we are given on the right-hand side. So A1 goes there. Then we multiply it times R. And the power on the R is the difference of those two bases. So 4 minus 1, which is 3. And what this is doing is saying there are 3 terms between the first one and the 4th one. What would I have to multiply by 3 times to find that power? So bigger base goes on the left. Smaller base goes on the right. Times R with the exponent. That is the difference of your bases. So these two will always add up to this, okay? It is not always going to be 1 and 4. It could be, I could give you 6 and 8, and I could ask you for the first term. So you could jump around a lot like this, okay? So now plug in what you have. I have -4, nope, sorry, the A4 is 1/2. I have 1/2 equals A1, -4, R, I do not know, but it needs to be raised to the 3rd power. With me so far? Now I want to isolate R, so what do? Divide by -4, which is the same thing as multiplying by -1/4. I get R to the 3rd equals -1/8. How do I get rid of something raised to the 3rd power? Cube root it. That 1 or that negative can be in the top with the 1 or in the bottom with the 8. It doesn't matter. It just goes to one of those places, okay? So let's say we put it in the top. What is the cube root of -1? -1, right? And what is the cube root of 8? 2. So R, I now know, is -1/2. With me so far? This type of question would most likely be on the non-calculator portion, and you would need to keep that question exact. So you cannot cube root 1/8 and get a decimal. You'd have to keep it exact. All right, now I got to figure out my equation. So AN equals A1, which is -4, times the R I just found, -1/2 to the N minus 1. And then what was my end goal? To find the 10th term. So A10 would be -4 times -1/2 raised to the 10 minus 1. This becomes -4 to the -1/2 raised to the 9th. Now, even if this is on a portion in which you have a calculator, you have to keep it exact, which means I cannot do a decimal here, okay, and round it. I literally have to separate this out. So what would be -1 to the 9th? -1. And then 2 to the 9th, maybe you have a calculator so it can help you with the multiplication, but if you do, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. If not, you got to multiply it out. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2, 128. 128 times 2, 256. 256 times 2, 512. So again, even if you're given a calculator, you won't be able to rewrite this as a decimal. You would have to do 2 times 2 times 2 times 2 times 2 until you got to the 9th, okay? And then I want to see if this reduces. So does 4 go into 512? $128 times. Negative times negative makes this positive. 1 over 128. So if you had used a calculator and you wrote that as a decimal, it will be marked wrong. Questions so far? Okay, we're going to do one more and then we're going to save this sum for tomorrow. So this one says, find the indicated term of the geometric sequence. What's happening this time? It didn't even just give us an A1. And what else? Do you have consecutive ones? No, we're jumping again. So we got to figure out R by using that little trick we just did. So what goes on the left? A5 is going on the left. What goes on the right? A2 times R to what power? To the 3rd. 5 minus 2. Now plug in what you know. A5 is 2/3. A2 is -18. R to the 3rd. Now divide both sides by negative 18 or multiply by 1 over 18, negative 1 over 18. 2 goes into 18 9 times. I get negative 1 over 27 equals r to the third. I cube root both sides. And what's the cube root of 1 over 27? 1/3, and it would be negative, right? Because it's a negative 1 over 27.
And then since 6th and 5th and exercise,
So now you've got like different ways to approach this. So Bryce just said, can't you just, I have the 5th term, I only want to get to the 6th term. That's what I would recommend. You only have to multiply it once, okay? So I could take my 5th term, 2/3, and multiply it by negative 1/3. And I get negative 2/9. But let's say there's a bigger jump there. Now that we know how to manipulate our jumps, we could literally use either of those terms first. So if I want to find A6, I can find it 3 ways, really. What we just did, which was take A5 and multiply it times the R once. But I could also do A square or A2 times R to what power? 4. Or if I want A6 and I have an A5, I would multiply it times R to what power? 1, which is basically what we did, okay? So you can bridge the gap on any terms by using the exponent on the R. You could literally have done that second part 3 different ways. Questions? Okay, again, we're going to pick up on the sequences on the sum, on the sum of the infinite and finite sequences tomorrow. Your web assign is open. You can complete 1 to 7 tonight and then finish the rest for tomorrow is what I would recommend you do.